All right, my beautiful followers, good afternoon and welcome to today's class. In today's class, I want to take you through this beautiful piece of device, which we call contactor. A contactor is just a switch, and it is a switch that is operated making use of electricity. So it is not just a mechanical switch, it is an electromechanical switch. What that means is that before this switch will operate, you must connect electricity to it. All right? So this is a three-phase switch or a three-pole switch, as you can see, 1, 2, and 3. And then on the output side, you can see also 1, 2, and 3. So what happens here is that at this particular terminal, A1 and A2, you must connect these voltages, these signals, this operating signal, which are 220 to 230 volts at 50 Hz, or 230 volts to 240 volts at 60 Hz before this will operate. So how does this happen? You remember that I told you long ago that when you connect electricity to a coil of wire, that coil of wire will behave like a magnet. So inside this contactor, we have a coil at the base down here, and the coil terminals are A1 and A2. So when we connect this signal, the control signal, to these terminals, this coil, which is stationary down here, is going to behave like a magnet, and it will attract another moving part here, which will now make these terminals at this side to get electrically connected to these terminals on this side. Now, the terminals on this side are labeled L1, L2, and L3, which are line 1, line 2, and line 3. While these ones that are connected to the load are labeled T1, T2, and T3, which stand for terminal 1, terminal 2, and terminal 3. All right, so when we connect the control signal on A1 and A2, L1 will connect to T1, L2 will connect to T2, and L3 will connect to T3. All right? So if you have a question on this, you can just drop on the comment section. And then we have ITH here. This stands for the conventional thermal current. What that thermal current stands for is the maximum current this contactor can handle without overheating. That is the maximum current this contactor can handle for a prolonged time, typically about 8 hours, without overheating. And that current is rated at 275 amps. All right, on this side we have IE-AC1. IE is just the operational current, and AC1 stands for non-inductive loads. For example, our electric heaters. So what this means is that for you to use this for electric heater, the maximum current this can withstand is 275 amps. And then, of course, the operational voltage is 1000 volts. That is the maximum voltage you can allow to pass on the contacts of this contactor. All right, so down here we have different operational voltages on this row. We have different operational voltages. Now, what this means is that at 220 to 240 volts AC, this contactor can handle 55 kilowatts of load. And this AC3 stands for inductive loads, like electric motors. All right? So when we operate this at 220 to 240 volts, it can take a load of 55 kilowatt. And when we operate it between 380 to 415 volts of 55 kilowatt. And when we operate it between 380 to 415 volts, it can withstand a load of 90 kilowatt. And when we operate it at a voltage between 660 volts to 690 volts, it can withstand a load of 132 kilowatt. And then when we operate it at the maximum voltage, this is what is going to take, about 132 kilowatts as well. So this is what this line stands for. And then, of course, this one means that this device is compliant with these two standards, the IEC standards and the EN standard. All right. And then here we have use Cal 18 aux block. All right, this Cal 18 aux block is a kind of auxiliary block that is recommended for this device, and that is installed by the side of this contactor. It can come to this side or it can come to this side. And this is what Cal 18 aux block looks like. All right, so it is written here, both like this and then of course on the other side. All right, so for us to attach this aux block, this auxiliary block to this contactor, we need to follow a simple rule. Now, looking at what we have here, we have these 3 studs, 1, 2, 3, and then we have these 3 grooves here, 1, 2, 3. And then we also have this one here and this one here, and then we have this place and then this one. And then we have this one here sticking out like this, and then we have this groove here where it's supposed to go in. So for us to attach this, we must align this 3 to this one. And then when we align it, we're going to lift this one up a little bit, press this one down, and make sure this pin here goes inside here, and then it will latch. So for us to do that, I'm going to make use of a few tools to enable me achieve it. So first of all, I will align this. Now I've aligned it. The way it is now, I've aligned it, but it hasn't gone in. You can see there is a gap here. This gap here, for us to make sure this latches properly, I will have to, first of all, lift this one up. I lift it up, push this one down, and then it goes in, and then it latches. So this is how it is installed. So for you to remove this one, the auxiliary, you turn it this way. You see this button here, you push it in. When you push it in, you lift this one up. After lifting it up, you push it away this side. When you push it away this side, you press it down, and then this will come off on its own. So for us to achieve that, press this in first, lift it up like that, take it backward like this, and then push it down like that, and then off it goes. I hope that is clear. All right, so we'll come down to this side. Coming down here, we have this other table here, which is provided by the underwriter's laboratory. And this one gives us the specifications in case our load is rated in horsepower. These are 3-phase voltages, different 3-phase voltages, and then of course different horsepower ratings that this contactor can handle. For example, when we have 200 to 208 3-phase voltage, this can handle 50 horsepower. And then 220 to 240, 60 horsepower, 440 to 480, 125 horsepower, 550 to 600 volts, 150 horsepower. And then down here we have a design instruction for electric motors, which is maximum of 250 amps at 600 volts AC. So, if you like this video, you let me know in the comment section, and if you have any question, please drop it in the comment section, or you send me a private message. And of course, please continue to stay connected with me for more tips on power. Thank you very much.